Hello everyone, welcome to Chemazon Complete Chemistry. So in today's video we are going to solve question 31 of the GATE 2022 chemistry paper, which is based on phase diagram of the phase equilibrium chapter. Question is the correct statement or statements about the following phase diagram for a hypothetical pure substance X. What is hypothetical? Hypothetical means unknown or imaginary substance X. Statement or statements means it is a MSQ type of question. Although in the exam, if you see at the side, it will be written multiple select question. Okay, but even if it is not written from the question, you must know how to identify the type of question. So, and what else you will get? The boxes will be square. Okay, square boxes means it is a MSQ type of question, that is one or more than one correct answer. One or more than one correct answer. Okay, so first option is the molar volume of solid X is less than the molar volume of liquid X. So before understanding this, let us first understand solid, liquid and gas. The line between solid and liquid, this is called as the, okay, where solid and liquid will be in equilibrium, this is called as a melting curve. Okay, melting, solid to liquid is melting, or it is also called as freezing curve. Liquid to solid is what? Freezing. So melting or freezing curve. Then the curve between liquid and gas. So here liquid is in equilibrium with gas. This is called as evaporation or boiling curve. Boiling curve. And the curve between solid and gas, that is what? Sublimation. So this curve is called as sublimation curve. Okay, this was the information about the different types of curves. Now we can solve this. Molar volume of solid X, solid is less than that of the liquid. So if you see the phase diagram of water, this is the phase diagram of water. Here if you see AD is the melting curve. Okay, between this is solid, liquid and gas. Okay, solid and liquid are in equilibrium. This is the melting curve. So it is what? It is a negative slope. So why this is negative? Because we know in liquid there is anomalous behavior or strange behavior of the water molecules, that the volume of solid phase, that is ice, is greater than that of the liquid water. Okay, that is the intermolecular distance in between the water molecule in ice is much higher as compared to that in liquid. Normally we know the volume of solid is what? It is less than that of the liquid, but only in case of water the volume of solid phase is greater than that of the liquid phase. Okay, so this phase diagram of unknown substance X also, you can see this is a negative slope. So here also the volume of solid, molar volume of solid will be greater than that of the liquid. So but in the question it is given it is less. Solid is less, volume of solid is less than that of liquid. This is incorrect state. Okay, next is X does not have a normal boiling point. Now what is the meaning of a normal boiling point and a normal uh, boiling point, normal melting point or a normal sublimation point? What is the meaning of that? You have to, at 1 atmosphere or atmospheric pressure, you have to check the temperature. Atmospheric pressure. Okay, at 1 atmosphere what you will do, you draw a line perpendicular to, sorry, parallel to the x-axis, that is temperature axis. This point you can see it lies on the melting curve, so it is written as normal freezing point or normal melting point. At 1 atmosphere you can see one more point is present at the evaporation curve, so that is why this is called as a normal boiling point. Okay, so in this, for this substance you can see at 1 atmosphere line there is only one point. This point, this is at the intersection of sublimation curve. This is on the sublimation curve, so we call this as normal sublimation point. Okay, so at this 1 atmosphere line, can you see any other point on the curve? No. Okay, there is no normal melting point, no normal boiling point. So this statement B is correct. Okay, X does not have a normal boiling point. Third option, melting point of X decreases with increase in pressure. Melting point of X decreases with increase in pressure. Okay, so let us see this statement. Melting point. So which curve we have to check? We have to check the melting curve, that is this line. Okay, suppose I take this temperature is, let's say, T1. Okay, now what we have to do is we have to increase the pressure. Okay, so let's say this initial pressure is what? P1. Okay, now I have to increase the pressure. Let's say my final pressure is this. So we have to check what happens to the temperature. So let's say this is the point, okay, on the curve. So this, if I extrapolate down on the temperature axis, you can see this is T2. So what is T2? T2 is less than T1. So as we increase the pressure, what is happening? Temperature is decreasing, or melting point is decreasing with increasing pressure. So third option is correct. Now let us see the last one. Last statement, what it is saying, that on increasing the pressure of the gas isothermally. What is the meaning of isothermal? Iso means same, thermal means temperature. So keeping the temperature constant, it is impossible to reach solid without reaching the liquid phase. So what they are saying is, to get gas from the solid directly, this is not possible. Solid, first it will getting converted to liquid, and then liquid can form gas. So let's say I take this point here. Okay, isothermal means I have to keep this temperature T dash, let's say, constant. So what I have to do, I have to increase the pressure. So I will move above. So now it was gas. Now let's say I have reached this point. Now this point is in the solid region. So you can see I have directly moved from gaseous phase to solid phase without getting into the liquid phase. Okay, liquid does not come. Solid gas can directly convert to solid, or gas can directly convert to form solid. So they are saying it is impossible, but just now we saw it is possible. So last option is incorrect. Okay, which options are correct? The only correct options are option B and option C. I hope you have understood the solution. Thank you.